Okay, so today's notes are going to be on algebraic expressions, and our content objective is going to be to evaluate algebraic expressions and simplify algebraic expressions. Our language objective will be to express written statements in the form of algebraic expressions. So we're going to practice some standard algebra stuff that you guys may have seen before, as well as practice writing some word problems into algebra, or turning word problems into algebraic expressions. So we're going to jump in with an example, and apologies in advance for the longer writing. It's going to be a word problem, so just a warning. So in football, a touchdown or TD is worth 6 points. An extra point kick or EPK is 1 point. And a field goal or FG is 3 points. What algebraic expression models the total number of points that a football team scores in a game, assuming each scoring play is one of these 3 plays, or each scoring play is one of the 3 types given. So sorry for the long problem to start, but I want us to practice putting these word problems into algebraic forms. So the first thing I want to do is to sort of break down this word problem to make sure we're understanding what we're doing. So I want to start by listing what we know already. So given the information in this word problem, we know the number of points each play is worth. The next thing we need to think about is what we're going to need to solve this problem. And so we need an algebraic expression. That's what it's asking us to do, so that's what we know we need to get to. So to get there, I need to plan. So my plan needs to include determining my variables, and writing the expression. Okay, so that's, before you start a word problem, these are some helpful things to run through. So think of what you already know from the problem, what you're going to need, and then plan how you're going to get there. So we're going to determine our variables, then write an expression. So then when we actually start sort of jumping in and executing our plan, I want us to start by relating the information we know. So the first thing, we know our number of points each play is worth. So let's start with the first one they list, a touchdown. We know a touchdown, number of points per TD, which we know is 6, but we know if we're trying to think of how we're going to figure out the total number of points in the game, we're going to have to think about how these relate to the total number of points in the game. So if I take my points per TD, or touchdown, and multiply it by the number of touchdowns, then that will give me the number of points per touchdown. If I add that to the number of points per EPK, or extra point kick, multiplied by the number of EPKs, then I'll have the total points for those 2 types of plays. And then last, if I add the number of points per field goal times the number of field goals, then add those all up, I'll have the total points. So if I relate all the information I know and I'm talking about, I can come up with an equation like this. So points per TD times the number of TDs plus points per EPK times the number of EPKs plus the number of points per field goal times the number of field goals gives me the total points. So I've written an equation, and though I've written it vertically, it's still an equation that tells me how I can find the total number of points. The next thing I want to do is actually define and choose the variables I'm going to represent. So I'm going to say that TDs will just be T, EPKs will just be K since they're kicks, and field goals will just be F since they're field goals. So I've now defined those three variables because in a game, I don't know how many touchdowns we have, I don't know how many extra point kicks we have, and I don't know how many field goals there will be necessarily. So I'm trying to figure out the number of points scored in the game. I'd have to know each of these bits of information, and I don't know them at this point. So now I'm going to substitute them into that equation we've come up with, and I can now write it horizontally since I have a little more space. So I know my points per touchdown is 6. So I know 6 times my number of TDs will be 6T. And then I'm going to add that to the number of points for the extra point kick, which is just 1. So plus 1 times EPKs, which I've defined as K. And then field goal I know is 3 points, so plus 3 times the number of field goals, F. And there's my algebraic expression. So all I did was sort of break down what I already knew. So I get the total number of points by multiplying the number of touchdowns by the number of points per touchdown, and same for EPKs and FGs. Add them all up and I get my total points for the game. Then I just substitute in variables for each of my unknowns, and I have my algebraic expression. All right, so that's all for that. Make sure you write down questions on this. I'm going to give us, or have us practice actually substituting in here. So I'm going to use this equation in just a second, but I'm going to turn this page for more space, so follow along. So suppose a football team, for the part 2, scores 3 touchdowns, 3 TDs, 2 EPKs, and 4 field goals. How many points did the team score? So for this problem, I'm going to write my expression, and if I hadn't already written my expression in the previous problem, you might have to go back and do all that process. But since I previously wrote it, I'm just going to copy it over again. So it's 6t plus 1k, or you could just write k, plus 3f. And then all I'm going to do is substitute my values in. So I know that 3 is my number of touchdowns, so I can plug that in for t. So I'm going to do 6 times 3, since there are 3 touchdowns, plus 1 times k, which would be 2, since there are 2 EPKs, plus 3 times 4, because there are 4 field goals. And then I'm just going to evaluate that, or calculate that out. 6 times 3 is 18. 1 times 2 is 2. 3 times 4 is 12. And if I add those up, I get 20 plus 12, which is 32 points. And that is my answer. So if they ask you to evaluate something, it means you actually are plugging in for variables. So if you come across those problems later and it asks you to evaluate, you are just substituting values in and then calculating out accordingly. So a couple more things. So some vocabulary associated with algebraic expressions. So I'm going to give us an example expression. I'm going to use negative 4ax plus 7w minus 6. And so first of all, this whole thing is called the expression. So first of all, an expression does not have an equal sign. It's like one side of an equation, so it's just this part, or it's just, there's no equal sign. Coefficients are the numbers that are attached to variables. So these two numbers, -4 and 7, are both called coefficients. So coefficients are the numbers attached to variables. And then last but not least, -6 here is our constant. So a constant is a number that does not change and is not attached to a variable. So in this case, -6 does not have a variable, so it is our constant. All right, so those are some important vocabulary words to know. Make sure you recognize which parts they represent in an expression. And then we have one last example before we go. I want us to simplify the following terms, or this following. So it's 7x squared plus 3y squared plus 2y squared minus 4x squared. So we have an algebraic expression because there's no equal sign, and I want us to simplify. So I'm going to do some 2-column notes. I'm going to start by rewriting my expression here. So 7x squared plus 3y squared plus 2y squared minus 4x squared. And the first thing I'm going to do is identify like terms. So just to jog your memory, like terms are things with the same variables that have the same exponent. So in this case, if I look at my 7x squared, I also have an x squared over here. So I know that those two things are like terms. They both have x squared attached to coefficients. So coefficients with x squared. There are no other variables with them. There's only the x squared, so I know those are like terms. Similarly, y squared and y squared, so there's no other variables attached. They both have the same exponent. They are like terms, and I can combine them. So I'm going to then rearrange this. And if, as you get more practice, you might not need to do this step, but I'm going to use the commutative property of identity. To rearrange these so that they are, the like terms are next to each other. So I'm going to keep 7x squared in front, but I'm going to move -4x squared towards the front, plus 3y squared plus 2y squared. So I moved that there so I can put them next to each other, and then I'm going to actually combine like terms. So 7 minus 4 is going to leave me with 3x squared, and then 3y squared and 2y squared gives me 5y squared, and that is my simplified expression. So after I combine like terms, I just add or subtract their coefficients, and that will give me the simplified term. I'm going to do a quick check and then we're all done. So again, I want you to simplify this equation. Negative, open parentheses, 3k plus m plus 2, open parentheses, k minus 4m. So go ahead, try that one on your own. I just want you to simplify it. If you haven't done it, pause. I'm going to go over it now. So the first thing I'm going to do is distribute my negative in. So if it helps, you can imagine this is a -1 that you're distributing in. So -1 times 3k is -3k. -1 times m is -m. And then I'm going to distribute my 2 into each term. So 2 times k is 2k. 2 times -4m is -8m. If it helps, we can then rearrange using our commutative property of identity. So I can make -3k plus 2k minus 8m minus m. And then I combine my like terms. So -3 plus 2 is still -1, which I can just leave as -k. And then 8m minus m is -9m. And that is my simplified expression. All right. Make sure you write down any questions, comments, or concerns you have on these notes so we can go over them together in class.